Hello, Namaste. I'm back with the module 2, the lecture 2, which is uh, where we would be trying to understand again the real word to a digital word. So we'll look at models here, specifically how the models are built, why there is a complexity in real word representation, and how do we actually represent a real word. It is not, as I said in my previous lecture, it's not so easy to represent a real word phenomena in terms of a digital word. So how do we convert a real word phenomena, how the real word phenomena is actually approximated in a digital word phenomena. So that is what we would understand in this particular lecture. So the concept that I would cover in this particular lecture is what do you mean by a data model. I would revise what do we understand by a data model basically. Then I would look at objects and characteristics, which is how it is actually represented. Then we would also look at how we graphically represent an object. So whether it is in a form of a grid, whether it is a form of point, line, polygons. So how do we actually represent an object? Then we would look at what are different of layer grids and object attributes, what are different attributes that are there in this particular transformation of a real world data into a digital world. So when we look at a data model, as I said, a real world data model facilitates the study of selected area of application by reducing the number of complexities considered, which means say that it is actually helping us to understand how the real world phenomena is there, which is quite complex, which is quite dynamic, by converting it to a data model and querying it for any instance of usage that we may require into. So it is facilitating any area of study which we would have collected and stored it as a database at any point of time. If a real world model is always to be used in any use, it must be in a form of a database. That is what I meant all along when I am actually representing the entire real world to a data model. So when we are looking at a data model, always it is all about storing your data in a database, converting your data into a data model and storing it as a database. That is what is extremely important, the way you think about a data model. So when we look at the entire data model, when we look at the geometric objects in the real world, for example, as I said, there may be a number of trees around this particular building, there may be number of roads that are actually connecting in this particular area, and there may be number of buildings in this particular area. So each of these are represented as point, line and polygons in a vector data. Okay. So when we look at this data, huge number of geometric objects are there. So manipulating of this geometric objects, so these are these start to be used in a form of a data models. So when we are looking at data models, each of these objects are nothing but your information. These are the ones which actually carry your information. So we call it as a carrier of information in a data model is nothing but an object. So when we are looking at this, these correspond to entities of the real world models and are therefore regarded as a database descriptors. So when you look at the entire real world phenomena, these becomes data descriptors also as the carrier of information of the real world in for the data model. Okay. So the point, line and a polygon in a vector model is now called as a descriptors, real world descriptors or your information nodes. So when we are looking at the entire data model, you have the objects that are defined by identity. So you have various objects in that particular data model that are represented in the form of identity and are characterized by, you may have type, you may have, for example, I did give an example of a road. Then you have attributes that may be qualitative, quantitative, it has always relationships. Then you have a geometry which is connected to it, so point, line and a polygon, and you have a quality, that is the accuracy and the extent and representation. So how do you understand what are the things that are there in this particular data? So you should remember that I had already spoken, you will always have a metadata. Having a metadata is extremely important in order to understand all of these aspects when you are looking at the entire data model. So, identities designation by numbers are extremely unique. No two objects will have the same identity. If though two objects have the same identity, then it means to say that it is actually giving you a bad result, because your database would not be able to handle both with the same identity, and finally you would get you may get a wrong result, or you may not even get a result. So that is how a database works. So you should always have a separate identity. So as I said, an object ID should be completely different. So when we are representing a real word, now let's go back to the model, the real word to the digital word model. So when we are actually representing a real word models and entities normally cannot be easily put into the data model, because these are not these are a single entity, but may have several objects, several hundreds, thousands, lakhs of objects. So representing that is quite extremely difficult. For example, you have a particular region here. If I have to represent all of these buildings in that particular database, so representing this, collecting this information has to be extremely accurate, and all the attributes that are there for each of these, which for different applications is needed as you determine. So this has to be done more accurately. So determining this is extremely difficult. But if I consider, for example, let us take this particular road which is called a church road. Okay, so if we take if we consider this, it has different sections of roads, it has an intersection, then each of these have an information, right? So when we are looking at this information, when I say information, the size of the road, the length of the road, then on the side of the road you have number of buildings, which are again represented as entities. So each of the building size, each of the building information, whether what kind of building, commercial, industrial or residential, so that kind of information is associated with it. So representing this is what makes it more complex. So this complex handling can be done with GIS, but the data that is collected must be handled in a very cautious manner, and most importantly, it has to be a good data. The data collection should be extremely data collection is what makes it extremely complex. And when we look at this implies the information carrying units and their magnitudes must be selected. That is what I meant. So before you go to the ground, before you understand on the ground what kind of information you need, you have to make a list of information that you may need when you go and collect a data. Information that a particular person needs and other person needs may not be the same. So what kind of information for your analysis is required has to be first and foremost determined. Once you determine the information and the data need, you go to the ground and then look at what are the different data that you have to collect. It becomes extremely easy for you, and the data quality would be much better. Otherwise you will be scrabbling with information, some data would be actually missing in certain entities, and that may lead to issues with your databases. Okay, for example, as I gave an example of this road, if you want to divide this roadway into different sections, it will be selected before that roadway how this particular roadway is described. Can the roadway be described in a proper manner? If it is described in a proper manner, then it can be divided into different sections. Okay, so the first thing is look at the road, understand the characteristics of a road, and understand what is the headway of that particular road. So then you will be able to understand what are the different sections, how can you define these sections, what are the different information that has to be collected for each of the sections. Then when we look at the type codes, is the thing that is actually another point is extremely important. I spoke about the IDs before. So these are based on object classifications, which are usually transferred from entity classification. I'll show you when I'm explaining the database how these object classifications are done using the type codes. and an object may be classified under one type code only. So, this is what is you may call it as a limitation, but it's also an advantage. So, it can be only one type code. If you have multiple type codes, then you are actually losing it on multiple fronts, because you may not get the exact data that you may be looking in to fit into the data model. So, it has to be only one unique type code for every classification or every entity. So, data models may be designed to include a physical object. You can have physical objects, as I previously said, in a form of a geometry. So, it is road, water mains and its properties. Classified objects, it can be types of vegetation, climate zones, age groups. So, these are different types of classifications. Events, whether it is accidents or water leaks, for example. Then continuously changing objects, for example temperature, precipitation. If you have a real time sensing, it can be easily fed into the database without much hassle in today's scenario. Then you have artificial objects like elevation, contours, population density. So, these are just a selected representation and of a data, and databases are in the form of a raster model. So, you can have any kind of data that is connected, any kind of attributes that is connected, any kind of geometric data that is connected with relationships. So, this data model can have all of these, but please remember that the type codes or the unique IDs must be completely unique. That is why it is called as unique IDs. So, it should be completely unique, so that you get some valuable outputs from that database. So, when we are looking at the graphical representation of these objects, as I previously said, these objects can be entered in terms of points, where you have single xy coordinates. It has 0 area, it is only representing that particular coordinate, particular point. If you, for example, when you look at you are going from one place to another. So, the first thing is, if you are putting a point in your Google Maps in your mobile, so that point is representing your place of stay. So, that is a point. So, then you will give the point of destination. So, that is nothing but a line. So, two or more connected xy coordinates connected points becomes a line. So, it is always one dimensional, it gives you the route. Okay. If you are representing the entire dimension of where you would actually stay, then it becomes a polygon. Your house is nothing but a polygon. Number of connected lines is nothing but a polygon. So, number of points can be represented as line, number of line segments is then represented as a polygon. So, connected line segments, a closed line segment is nothing but a polygon. So, when we look at points, a point is the most simplest graphical representation of an object on the earth's surface. So, be careful. So, you are representing an object, okay. You are not representing a phenomenon or area, it is an object. So, in a large scale representation, a building may be shown as an area, whereas it may be only a point. So, this is where people make a mistake. So, when you are representing a large scale, you represent it as area, but it is a point only if the scale is actually reduced. When you are actually looking at the entire image, so buildings can be a point, can be a polygon. So, it is dependent if it is a very large scale region, because if you are looking, for example, if you are looking at the entire campus of IIT Kharagpur, then I focus only on a particular building and try to map it, maybe 3-4 buildings, then it becomes a large scale map. So, you have every information about those 4 buildings. So, this can be represented as a polygon, whereas if you are looking at the entire IIT Kharagpur, so each of these buildings is nothing but an point. So, that is represented as a point. So, when we are looking at lines connect at least 2 points. Lines always has 2 points. So, they connect at least 2 points. So, and are used to represent objects that may be defined in one dimension. I gave an example of your house and your destination that you have to reach to so that you used your Google map. Then you have properties. Boundaries are typically lines, as an electric power line, telecommunication lines, cables, etc. Roads and rivers, on the other hand, may be either lines or areas. So, you should be extremely careful. Roads can be lines in a very coarse resolution data. If you have a very good resolution data, then roads can be even polygons. Okay. So depending on the scale that you have used, then if you are representing polygons, polygons are used to represent objects defined in two dimensions: a lake, a area of a forest, a area of a building, a area of a town. These are represented by areas or polygons. Again, when you look at the physical size in relation with the scale, determines whether an object is represented by area or a point. I've told you this before when I'm explaining the point. So what kind of scale that you are actually representing, whether you are representing the entire IIT Kharagpur campus or representing only the 4 buildings in IIT Kharagpur campus. So if you are representing 4 buildings in IIT Kharagpur campus, each of building becomes an entity, and each of these buildings will be in a polygon shape. But if you are trying to take the entire vast campus of IIT Kharagpur, supposed to be the biggest campus in IITs, so each of these buildings will become a point. So please keep this classification in mind. An area is delineated by at least 3 connecting lines. You should have at least 3 connecting lines to make it a polygon, each of which comprise of number of points. As I said, number of points form a line, number of line segments form a polygon. So this loop has to be understood properly. So when we are looking at the graphical representation of point, I am trying to revise what I spoke in last few slides. So points are 0-dimensional object that gives you a specific geometric location through a set of coordinates. Then line segments, a 1-dimensional object that is directly a line between 2 endpoints, 2 points that are actually connecting. Then you have a string, a sequence of line segments. So number of line segments, so that also can be representation of your root. Okay, so if you are looking at a polygon, a 2-dimensional object bounded by at least 3-dimensional line segments. Okay, so finally I would like to introduce one more concept here, is a raster. So what we are looking, so vector data model. Now if we look at a raster, is number of cell or a pixel. This I have spoken in the previous lecture. So if you zoom in your photo, you can see a completely a box. If for example, you can just take a photo in your mobile phone and keep on zooming it until you find only boxes where your software would not be able to zoom in further. Okay, so look at that. So those are called as pixels or cells. So collection of these pixels in a definite number of rows and columns represents an raster image or a raster model. Okay, any of your photos, satellite data, any of your images that have been considered is a raster data. Okay, in the form of a photo, etc., is a raster data. So this can be again associated with geometric objects, it can be associated with geographical data, it can be associated then with the database. So it depends on how you are actually categorizing this raster data. So when we look at the raster data, the next concept that we have to understand is grids. So for example, on your right hand side, I have represented, if I have considered this particular area in a particular region. Okay, so if I am representing this area in a different region, I would, if I classify it as residential, commercial, forest, agriculture, water and unmapped. So what I do is I define this in equal number of grids. Okay, so number of straight lines that are intersecting at a like number of points. So it is equal number of square boxes. Fine. So you have equal number of square boxes. So each of this box representing a polygon. Okay, so always when we are looking at technically the vector model, so we, or a raster model, we use the terms point, line and a polygon, and grids or pixels, etc. Not we do not use terms such as area. So when we are looking at this, these are number of polygons that have been represented. Each of polygons are represented by real world objects, okay, which are in regular squares and have all terms of the area. These are representing each area. So all of these polygons have each areas, each, for example, this residential area is represented this classification. So wherever you find this particular of this particular classification symbol, so that is nothing but a residential area in this region, right. So this is how the data is represented as a grid. So the grid data is a collection of cells, collection of equally spaced equal area cells, or if I have to say technically number of polygons. Each of these polygons have real world information. All real world information is then coded in terms of certain classification procedures or classification types. So each of these classification types are is as mentioned here. These are different codes. This is just an example. So there are a lot of what we call it as cartographic instruments. The way we want to classify, based on those instruments you can look at the representation, but normally you have a certain standards of representing each and every object. So that is how it has to be represented. You cannot have your own way of representing every phenomena on the earth surface. So finally, when we look at when we have looked at grids, we have something called as object attributes. So heights are treated as attributes to objects, not as a part of a geometry in the layer based model. For example, what I am speaking about is a previous example which I was speaking about the buildings. So normally heights can be treated as attributes to objects, okay, not as a geometry. If you have a geometry of a building, let us say you have given an example of IIT Kharagpur. If they have collected information about 4 buildings, let us say I have first building is computer science, other building is electrical engineering, third one is you have a PCBA block where my particular department is there, then you have maybe chemical engineering. So when we look at all of these 4 buildings, okay, if I am trying to give you an height of a building, then it becomes an attribute of an object or an entity, okay. Rather, the geometry of a building, for example, what is the way that building is represented, whether it is square, whether it is hexagonal, or whether it has a random shape, or whether it is a rectangle, or whether it is a circle. So all of these becomes a geometrical shapes, okay. This becomes a geometrical way of representing that particular object, but height is always an attribute. This is where students actually make a mistake. So always they try to put height as a geometry. So once you put height as a geometry, then it is actually representing a 3D format of that particular data, which is actually not representing the relations, okay. But you can form relations from a 2D data to a 3D data, okay. So when you are looking at object attributes are the same as entity attributes of the real world models, okay. So that is what I said, object and entity go hand in hand. Object attributes are always same as the entity attributes. Object attributes are stored in tables with objects as lines. So this is a thing that everyone has to understand. Object as lines, okay, on lines, and attributes in columns, okay. For example, I have a table here which is actually connected as a database. So when you look at this, these are different objects that are represented here, cell number 1, 2, 3, 11, 12 to n. So these are nothing but objects, whereas these are those attributes that are stored in each of this cell. So that is where you have an object, you have number of attributes that is actually connected to a cell. So to summarize this particular session, we have a real world model that actually reduces that has complexity, but you have to reduce the complexity in order to put it into a data model. So real world model connected to a data becomes a database. So once you have represented in a data model, so it becomes a database. The database always has certain geometric information. These are nothing but your carrier of informations, okay. I spoke about the point, line and a polygon. These represent different information, different size of information, different entity of information. So these are nothing but having different kinds of information embedded. So we have object characteristics, for example, the type, the attributes, the relations, the geometry and the quality. So these are different object characteristics. Then you have a data model design. So I will go into details of data model design but as of now please understand it's in the form of grids, in the form of attribute, how the attribute, the objects are actually put in the form of a gridded data. So then you have graphical representation of points, that is in the form of a point, line and a polygon. So we have looked at object and attributes, how the objects are put in. You always, objects are in the form of a number of rows, and you have columns. Each of these columns are represented in a form as attributes. So object and attributes, so these have relations. So as of both of this class, so the very important concept that we have learned is how the real world translate into a data model. So now the next session of the lecture, we would look at how the object relationships are maintained and what are the different shortcomings of these models, these GIS models, and how do we look at this GIS as a tool which can be extremely useful in our analysis. That is what we would look at. So that's it for today. Thank you very much.